So we're going to find the integral of x lots of x squared plus 1 to the power of 5. What we have to do here is we have to use the chain rule formula that is on our reference sheet. So this formula is the integral of f dash x times fx to the power of n is equal to 1 over n plus 1 of fx to the power of n plus 1 plus c. Alrighty, so what we have been given here is we have x times x squared plus 1. This is where our fx is what's out inside our bracket, which is x squared plus 1, and the derivative of this is equal to 2x. So what we are meant to have is we have the integral of x lots of x squared plus 1 to the power of 5 dx. Our value or our pronumerator at the front is meant to be our derivative of fx. However, we only have an x here. So what we have to do is we're going to make that x a 2x, and we have to multiply it by what gets rid of the 2. So what I mean is we're going to go a half times our 2x, which is our derivative at the front of our bracket, multiplied by our bracket. Okay, so what we are doing is we are substituting in our derivative of fx, which is 2x, and we're multiplying it by a half to get rid of the 2 so that it is equivalent to the x. What we're going to do from here is we're going to bring out the coefficient of a half out the front so that we're just left with 2x bracket x squared plus 1 to the power of 5 dx, which is equivalent to our f dash x of fx to the power of n. What we do now is we find the integral by leaving the half out the front and doing a square bracket. So we're going to have a half times 1 over our n is 5 plus 1, lots of our bracket x squared plus 1 to the power of 5 plus 1, and we will just have our plus c on the end. So this is a half times 1 over 6, lots of x squared plus 1 to the power of 6 plus c. So we have a half times a sixth is a 12th, lots of x squared plus 1 to the power of 6 plus c. Okay, let's try that again with a little bit of a harder example. So what we have here is we want to find the exact value of the integral of 1 to 4 of x squared bracket, x squared the square root of x cubed minus 1 dx. So the first thing we want to do is we want to write down this chain rule. So we have our integral of f dash x of fx to the power of n dx is equal to 1 over n plus 1 of fx to the power of n plus 1 plus c. What we have is we have the integral of 1 to 4 of x squared root x cubed minus 1 dx. We want to get rid of this root and write it in terms of brackets. So our integral of 1 to 4 is equal to x squared bracket x cubed minus 1 to the power of a half dx. We then want to look at what our fx is. So our fx is what's inside the brackets, which is x cubed minus 1, and our derivative of of x cubed minus 1 is 3x squared. So we have our integral of 1 to 4 of x squared lots of x cubed minus 1 to the power of a half dx. Now, what we want our derivative of our fx to be is 3x squared, and we only have an x squared here. So what we're going to do is we have our integral of 1 to 4, and we are going to multiply our x squared by a third and replace our x squared by 3x squared, because that means that a third times 3 cancels out to just leave us with the x squared, and then we will write down our bracket of x cubed minus 1 to the power of a half dx. So now that we have done this, what we want to do is we want to bring that a third out the front of our integral sign. So this will equal a third of the integral of 1 to 4 of 3x squared x cubed minus 1 to the power of a half dx. And now we have this in the form of our derivative, the integral of our derivative times our fx to the power of n. So we can now integrate this, leaving our a third out the front. So we'll have our third out the front, our 1 over a half plus 1, x cubed minus 1 to the power of a half plus 1. And then instead of writing a plus c, what we need to do is we need to put on our values that we're going to substitute in. Okay, now we need to tidy this up a bit. So we have that it equals a third bracket 1 over 3 over 2, lots of x cubed minus 1 to the power of 3 over 2, and we want to substitute in our 4 over 1. Again, remember that 1 over 3 over 2 is equal to the reciprocal of the bottom fraction, which is 2 over 3. So this is going to be a third, lots of 2 over 3, and we have x cubed minus 1 all to the power of 3 over 2 is the square root of x cubed minus 1 cubed. And our values that we're going to substitute in. And now it is time to substitute in our values. So we can do that. So we will have this equal to a third. And we can also bring our 2/3 out the front of our brackets and then substitute, because the 2/3 won't affect our values being substituted in. So we have 4 cubed minus 1 all cubed minus our square root of 1 cubed minus 1. So a third times 2/3 is 2 on 9 out the front of the 4 cubed is 64 minus 1 all cubed minus root 1 minus 1. So this is 2 over 9 root 63 cubed minus 0 cubed. So what this is equal is 2 over 9 in brackets root 63 times root 63 times root 63. So we will have that this is equal to 2 over 9. We know that root 63 times root 63 is just 63 root, and then we multiply by that root 63. And so then 2 over 9 times 63 is in fact equal to 14. So we have 14 root 63 as our answer there. So what you guys are going to do is you're going to complete exercise 705, question 1 to 4 ACE, and then question 5 and 6.